So now let's take a look at the second method. Okay, let's now go back to utility. So this will be the working version. You can definitely study that over here to see exactly how to make it work. So now let's now see the second part, the second method we would like. We want to print out column by column over here. So how would it work? So column by column would be something like this. We want to say for so the first one we want to print out will be 159, followed by, okay, let me do it again. 159, followed by 2610, followed by 3711, and also followed by 4812. That's what I would like to display. And we can assume that over here it's really important to have some assumption if you need it. We assume that it's going to be a rectangle, meaning that every array in the second dimension, they are actually going to have the same length. So for this one, we don't have to worry, although it might be a interesting exercise for you to say, what if I relax this particular assumption? How do I print column by column? It will be slightly trickier, but I'll let you figure out how to do it. It will be some extra exercise for you. Okay. Let's now see how we can print it out. It will be very similar code, except that we have to think about the indices. Let me just talk about this quickly to give you the insight, and then the solution will just be developed accordingly. When we do row by row, what we did was, if you think about R and C, the row and column, what's happening is when R is actually equal to 0, the row will be the column will be 0, 1, 2, and 3. So when the R is actually 0, we are referring to this particular row, and then the column should be 0, 1, 2, 3. And then when R is equal to 1, that means we're referring to this particular second row, and the column should also be 0, 1, 2, 3, right? That's basically what we did. And then, so also 1, in that case, that'll be 0, 1, 2, 3, and also 2, 0, 1, 2, 3, and also, oh, that's it, right? It's a 3 by 4 matrix. So this will be row by row, the blue one over here. So what about column by column? So what do we want to do? The column by column is going to be something slightly different. So rather than fixing a particular row and we try the various possibility for the column, we want to say fixing a particular column, we want to try the various rows, right? For example, fixing column 0, we want to do rows 0, 1, 2. And fixing column 1, we want to do rows 0, 1, 2. Right? Let's now write it down and see exactly how to compare the pattern. So how do we print out column by column? So row and also column over here. So fixing the column to be, let's say 0. Let's say 0 over here. And then the row can be either 0, 1, or 2. Right? So that will be, row will be 0, 1, 2. And then fixing the column to be 1. Right? The second column. And row can also be 0, 1, 2. And row can also be 0, 1, 2. And also for 2, it can also be 0, 1, 2. And for 3, it can also be 0, 1, 2. But the total number of elements that's going to be printed out will just be 3 by 4. Either 3 by 4, you can think about is either 3 by 4, or this will be 4 by 3. Right? So either way. So it's really something interesting for you to compare. Right? So when I say 3 by 4 here, I'm talking about out of the 3 possible rows, each one of them will have 4 possible values for the columns. And here 4 by 3 means out of the 4 possible values for the column, each one of them got actually 3 possible values for the rows, right? It's really symmetric. Okay, so we'll print out exactly 12 elements as well. Let's see how we can do it. Okay, I would suggest I will try to type the minimum possible so you can see it's very similar to the previous the row by row solution, which is going to modify the loop counter a little bit. Okay, let's just go back to here. Let's now write down the test first. Let me go back to test utilities over here, and then I'll simply copy this one over here and just paste. So I would say 02, test number 2. And then I'm now going to, I don't need to worry about this triangular shape anymore, right? Because I assume. Let me just say one more thing over here. If I go back to utilities over here, it's really important for you to document the assumption. So utilities over here, assumption, the input array is rectangular. Okay, I already defined what rectangular really means, but we will actually see later in the tutorial series this week. We also say given a particular input array, two-dimensional array, is it rectangular? That's something we'll do later. But for now, you can just understand conceptually what it means to be rectangular. Let's go back here, and then let's say the input is really the same, and then we're calling column by column. What will be the expected output? Okay, rather than this, right? Rather than this, it's going to be basically for column 0, and then we need to let's fix the column 0, and then for the different rows, you'll be 1, 5, and 9, right? You can see 1, 5, 9, 1, 5, 9, and also for the second column, so that'll be 2, 6, 10. 2, 6, 10. You can see each list over here is only of size 3 because we got we only got 3 rows. And then we also got 3, 7, 11. 3, 7, 11. And also we got finally the fourth column. It should be the first row, intersection with the intersection with the first row, 4, 8, and also 12, right? Intersection with the second row, intersection with the third row. So 4, 8, 12. All right, let's now see if that works. If I now try to run the test, I haven't really implemented it yet, have I? So I just defined the test case only. Let me go back to utilities. Of course, it wouldn't pass for sure. So what I will do is I'm just going to copy this fragment of code that's correct for row by row, and then I'm just going to paste it over here. All right, let me just fix the indentation over here. All right, so now how would you suggest me fix? Actually, since we are only just trying to say that the way we plan out the loop patterns for row by row, and then column by column, for the blue one over here, so R over here is the outer loop. So we will make sure when R is actually 0, we'll try out all the possible values for columns over here, right? So now we want to print out the reverse, the symmetric way, column by column and then row by row, right? So now for each column over here, so column value over here should belong to the outer loop instead. And then for each value for the column, we should also try out all the possible value for the rows. So we should just reverse the order for the 2 nested loop. That's basically what we're going to do, right? But you should also know, really this table over here summarizing the loop patterns for the 2 methods is really are really the key. So these 2 tables, okay? Let's now go back here. So what I will do is I'm just going to say, cut this, put it here, and then cut this and promote it to the as the outer loop over here. That's basically what I will do. Okay. Of course, now what should be this number here over here? You can see this. So when I say column over here, so what should I do? What should be the upper bound for the column? So basically, it would be the column we should try would be column 0, column 1, column 2, column 3, right? Since we assume it's going to be a rectangle for the input always, so we can simply so we know that each array in the second dimension will be equally long. So why don't we simply take the length of the first row? So it's guaranteed to be rectangle, right? If so we when we say we're assuming that it's a rectangle, we're also at the same time assuming that it's not empty, right? So why don't we go back here, and then we'll simply say a0.length over here. All right, so that'll work. I think that this is a critical line over here for you to know. Let me write it down. Since the input A is rectangular, it's not empty. So that means we can actually use A0. It's guaranteed not to have any array index out of bound exception. All right, so everything compiles. Let's now, oh, does it? Let's see what errors we have over here. Let's see, yeah, let's see what errors I got over here. I can see some red cross. I think we should be okay, right? Oh, over here. So what we need to do now is we also need to flip the, I think we also need to flip the order for the loop counter over here. So here, since we're now in the inner loop, we are going over row by row. So we should really change this from colon to R over here. And then, so here we should really change from R to C over here, right? You can see it makes sense. So in the outer loop over here, we want to make sure we actually put a comma separated between every column. And between every column, after every column, we should really put out the comma over here, right? You can see. After displaying this particular column, and then it will be separated, surrounded by the curly brackets, and then we want to put a comma, right? That's exactly what we did, right? So the compiler in this case very usefully actually caught the error for us. Otherwise, I forgot that I should do that. All right, so now everything is compiling. You can see it's also not exactly trivial to really just copy and paste. You want to be careful about really fix the symmetry. Let's go back to test utilities, and then we're going to say run. Okay, so we got some errors over here, but now we need to take a look at what's really wrong. Okay, why don't we take a look over here? Let's now run it again, and then let's now just double click on that. So it seems like we're having some trouble with the comma separated list, right? So 159 is also 159. It's just about the comma separated list. The comma should not be there. So I think we should. Okay, let's take a look. 159. Ah, I got it. Let's go back here. Utilities. You can see here, we should really be careful about this particular line over here, right? Since now we are talking about the row, right? So we're basically saying, for this particular column over here, we should really print out all the rows intersecting with that particular column. Should be column 0, column 1, and column 2. And then we should put a comma after this, and there should be no comma after the last row, which corresponding to 2, right? So if I go back to the code, currently I'm still using AR.length, which is not right. What should I fix? It should be R minus 1, right? You can see under the context for the nested loop for going row by row, I should really definitely put R over here. And then under the context for the column, I should really put over here. So rather than A.length minus 1, it should be the column, right? So I should say A0.length minus 1. That's what I should do, right? Again, you really got to fix the symmetry accordingly. So I think it's a nice bug, quite natural bug. So you definitely got to fix it. You can see you're not really supposed to really code up the correct version the first time. So that's why test case will be so nice to really help you, to guide you through towards the final ultimate correct code. All right, let's try it again. If I run it, I still fail. Let's see this. 159. So somehow I don't have a comma anymore. That's hilarious. So let's now go back to utilities over here. Let's see this. So what I should do is I should really say if R is less than, you know what? Should not be R. I beg your pardon. R less than R minus 1 is always false, right? What I really meant to say was A.length, of course. Because the number, I really meant to say number of rows. So that should be A.length, okay? So this will be the number of columns, okay? Let's now go back and then run the JUnit tests. Everything works. All right, it's quite a long process over here, but I think these two methods, even though conceptually they're very simple, you just want to print out row by row versus column by column. However, when you want to code them up, it's actually not exactly trivial. So you really want to think about what the difference is between the two. All right, it's really important. All right, so this really conclude the first problem I want to solve together with you. When you review this problem later, I would suggest you do the following. Not only that, you should only look at ultimately correct solutions for the both methods, which are pretty much symmetric to each other. You should also look at the intermediate solution that are actually wrong, in which case I actually showed to you how I actually click on the failure trace in the JUnit test panel, and also how I actually launch the debugger to really compare the array contents over there. So that's really something I think that's even more valuable for you. You can get out of this particular example. Especially, let's say, for example, in this case, rather than a.length, if I simply put a0.length, index at position 0.length, or over here, rather than a0.length, I can simply put r. So why would that be wrong? As far as this particular column by column printing is concerned, right? That's something you want to think about and convince yourself. So that will let you get more insight into the correct solution. All right, that's about it I want to say about for this first problem, and then let's move on to the second problem.